All right, everybody. We are in the process of changing gears, shifting gears, and we're going to head toward what's going to be called exponential functions and logarithmic functions. And in order to do that, there are some things we kind of have to be able to work out and know in advance. So there are some exponent rules that you should have learned at some point in the past, and I hope that you remember them and know what's going on and stuff like that. So first of all, let me talk about what an exponent looks like. So if you had something like y equals 5 squared, okay, we clearly know that that has exponents in it. This guy down here, the 5, is called the base, okay? And when you look at it in the font is written regularly, right? So it's a big font compared to the exponent up here, who is written in a smaller font. So it's not necessarily that it's a big number or a small number, it's that the actual size of it, the physical size of the writing is bigger or smaller, okay? So that's the base, the 5 is the base, okay? And the number up in the air, so to speak, is the exponent. So there's some stuff that goes on, and I just want to review the exponent rules real fast. And this will probably be about all we do on this video, just a real quick exponent rule review. So there's stuff that happens. So for instance, if I had, and I'm going to start with numbers, 5 squared times 5 squared, then we know that that's 25 times 25, right? So I can work that out. But we also probably should know, let me write 25 times 25, and what is that? I want to say 625, but let me double check on the calculator. Yep, 625. Okay, so we know that that's what's going on. But if I were to rearrange this just a tiny bit, I could also write it 5 times 5 times 5 times 5, right? Okay, because 5 squared is 5 times 5. This 5 squared is 5 times 5. So it's 5 times 5 times 5 times 5. And each of those technically has an exponent of a 1 written up there, even though I don't talk about it or write it or whatever. It's technically sitting there. So we know that if we had 5 times 5, that would be 5 squared. If I had 5 times 5 times 5, that would be 5 to the third. And here, 5 times 5 times 5 times 5 is actually 5 to the fourth. Okay, so what we know is that, and if I punched that on my calculator, let me do that, 5 raised to the 4th power. I'm using this little house top that's right above my division sign as the raise to button. You can use this square button for raising things to the 2nd power, but when I want a bigger exponent, I use the little house top thing, or it's called the caret button, and then tell it what power. So look at that, that is the same. So that is 625. So there's an exponent rule that says when you're multiplying things with the same base, you have to start with the same base. If this was 5 squared times 3 squared, I could not use this rule. Okay, I just have to multiply that out and see what I got. But when I'm multiplying things with the same base, the rule is, quote unquote, rule is, it's keep the base the same. And what we did was add the exponents, right? 1 plus 1 is 1. 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4. So add the exponents. That's what we're going to do. That's our rule for multiplying things with exponents that have the same base. Okay, so when I do that, I'm going to add the exponents, keep the base, add the exponents. So it ends up that a lot of this, of course, is not going to be with numbers. That's the nice case, right? Instead, we're going to have stuff like x squared times x squared. And those have the same bases. So I'm going to keep the base. It's going to be an x. And then it's going to be 2 plus 2 up here. So I know that's going to be x to the 4th. So what if it was something really big? What if I had something like x to the 8th times x to the 9th. Okay. Well, it doesn't matter how big the exponents are. I'm multiplying and they have the same base. So I keep the base, it's an x, and I'm going to add the 8 plus the 9. So it's going to be x to the 17th. Okay. So it's a pretty easy rule just by itself, but of course they have to be more complicated and things are going to get crazy on us and we're going to get other things going on. So that's that one rule. And it doesn't matter if it's x's or if we had like y to the third. Let's try this one. Y to the third times y to the -2. We're multiplying the same base, but what? The exponent, one of them is negative. So that would be y to the, add your exponents, 3 plus -2. Well, what is 3 plus -2? Well, that's 3 minus 2, and that's just y to the first, or just a y, right? Okay. And what if it was, let me throw another one out here. What if it was z to the second times z to the third times z to the fourth? Oh, now I'm multiplying 3 things, but they all have the same base. Well, it works the same. This is going to be z to the, because the base stays the same, 2 plus 3 plus 4, right? So 5 plus 4 is z to the 9th. So I can do this process repetitively. So it works the same no matter what we're doing there. There's also another exponent rule. So this is for multiplying things with the same base. That's that guy. Let me throw this one in here because a lot of times I actually get this one at the beginning. And it is anything raised to the 0 power is a 1. Okay, so it's not a 0, it's a 1. So let me show you how that works. Actually, stinker. Let me hold off on that one because the math for how it works is going to involve the next property that I use. So sorry about that. Let me get this other one in there. I started to do it first and I thought I'd throw in the 0, but I need to come back to it. So the next one is when dividing. When dividing things with the same base, so that's the trick. They need to have the same base, dividing same base. Keep the base the same and subtract your exponents. Okay, that's that guy. So in other words, let's look at that real quickly. Let's go back to the example where I had numbers. So that one tends to work pretty nicely for us. If I had 5 to the 4th, divide by 5 to the 3rd, okay, then what we end up with here, let me do this the long way. This is the same as 5 times 5 times 5 times 5 over 5 times 5 times 5, right? 5 to the 4th times divide by 5 to the 3rd. And so then you look at this and you go, okay, a 5 over 5, that'll be a 1, right? And that'll reduce out. And this 5 over 5, that'll be a 1. And this 5 over 5, that'll be a 1. So I end up with just a 5 on the top, okay? Or 5 to the 1st. Okay. So what we're saying is that there's an exponent rule going on here where this guy, and I mentioned it earlier in the semester, this guy is in the denominator, and we know that that means he has a negative exponent if I move this to the top. This is going to become 5 to the -3. So this is the same as 5 to the 4th times 5 to the -3. Well, now that's a multiplication problem. If I move the guy in the bottom to the top and make him a negative exponent, and be careful about this, because it's not a -5, okay? The 5 is still going to be the same base. We check it, 5 here, they have the same base. So we're not changing the 5, the sign on the 5. We're changing the sign on the exponent, okay? So when you pull this guy to the top, you get 5 to the -3, and then we can use our exponent rule that we had up here, where we said, oh, I'm multiplying things with the same base. I'm going to keep the base. And then I'm going to add my exponents, 4 plus -3. This is actually like the one we did right there, right? Where was it 3 and a negative 2. All right, 4 plus negative 3 is the same as 4 minus 3. That is 1. So this is just 5 to the first or 5. They're the same thing, right? So I could do that every time if I wanted to. I could move those things, the bottom term here, I can move him to the top, make his exponent negative, but it kind of gets cumbersome and it's a lot of work. So our exponent rule says when we have things with the same base, here we go, we're going to keep the base and we're just going to subtract the exponents. So we always start on the top. 4 is on the top. It's 4 minus 3. So 4 minus 3, still 5 to the first. Same answer, okay? But hopefully you can see why we're subtracting the 3. We're subtracting the 3 because this 5 went away, and this 5 went away, and this 5 went away. So 3 of those 5s will reduce out. We will be left with just one of the 5s, right? So somebody was playing with the patterns and saw, oh, well, that's the same as 4 minus 3. So I can just subtract the exponents. And that's exactly what we're going to do here, okay? So that's with, nice pretty numbers. Let's do 1 or 2 using exponents. So this would look something like x to the 5th divided by x squared. You look at that and you say, is that the same base? And if it is, they're both x's. So we're going to keep the base. It's going to be an x. And we're going to subtract the exponents, 5 minus 2. So this is going to turn into x to the 3rd. And again, if you wanted to check it, you could go x times x times x times x times x, because there's 5 of them on top, and x times x, because there's 2 of them on the bottom. And you could say those are going to go away and those are going to go away. And how many am I left over? X to the 3rd, right? So that's the math that's going on. That's what we're skipping whenever we use this rule, okay? So same thing happens as what we were doing earlier. So we need to kind of think about maybe weird cases that might pop up. So what if it was x squared divided by x to the 5th? What if it was opposite of what I've got there? Okay, x squared divided by x 5th. I'm still going to do it the same. It's still x is my base. Keep that the same. And the 2 on top minus the 5 will give me x to the, now careful because this is x to the negative 3, right? Okay. So the math behind that, what's going on with the x's is it looks just the opposite of what I just did here, right? I've got x times x on the top, and on the bottom, I've got x times x times x times x times x. And 2 of those will go away. Now they go away, but x divided by x is really a 1, right? So it was really a 1 down here. I just didn't write it because I know anything divided by 1 is that thing. And so, but here I'm going to need a placeholder because everything on top went away, right? So I need a 1 up there to say it's not just over x to the 3rd, it's going to be 1 over x to the 3rd, right? Because there's 3 left over. Okay, so we see this going on here and we say, okay, so that means that this better be equal to 1 over x to the 3rd. They're the same thing, right? So that is confirmation of our negative exponent rule, right? If you've got a negative exponent, you can move it. If it's in the top, you can move it to the bottom and make that positive. Or like we did here, it was positive in the bottom and we moved it to the top and made it negative. So as long as you move it in the fraction, either up or down, you change the sign. That's what happens, okay? So let me throw that in here, okay? When you move something with an exponent from top to bottom, or bottom to top in a fraction, then the sign on the exponent will change. Remember, we're not changing the sign on the base, sign on the exponent will change. Okay, so if it was positive, it would become negative, or negative becomes positive. Just depends on what I'm dealing with. Okay, so but if I move it from the top to the bottom and it has an exponent, then the exponent is going to change. If I move it from the bottom to the top, then the sign SIGN on the exponent will change. Okay, so that's the rule that I've been using the whole time. And we actually used this the other day and nobody fussed, so I think we're okay. So let's come back now. Are we all right with this? I'm going to come back now to this guy. Anything raised to the 0 power is a 1. Okay, so that rule that I mentioned earlier, anything raised to the 0 power is a 1. We're going to look at that because what that would look like is this. What if I had 5 to the 6th power divide by 5 to the 6th power? So for my example, I needed that division rule. So when I do this, 5 to the 6 over 5 to the 6, we know those will reduce, right? And I'll just get a 1. Okay, so we know what that looks like, but let you see the exponent rule part of it. If it's 5 to the 6th over 5 to the 6th, then I can rewrite that 5 to the 6 on top minus 6 on bottom, and that will be 5 to the 0, right? Okay, but because 6 minus 6 is 0, so we know that's 5 to the 0, but we know it has to equal 1. So, and it doesn't matter what the base is. Anything that works like this, if it was an x to the 6th over an x to the 6th, those would reduce out, it becomes a 1. So when I use this exponent rule and I end up with something to the 0 power, I go, oh, hang on a minute, that's, be careful, that's not 0, that's a 1. Those things will all reduce out and they will all become 1s. So that's to get back to that. Anything raised to the 0 power is a 1. Okay, sorry about that. All right, so these are the bulk of the rules that you're going to use, the add, the subtract, but there is one more that we absolutely need to have. So this one looks like, what if I had 5 to the 3rd and I squared it? Okay. Well, that would end up being whatever's in the parentheses times itself, right? So 5 to the 3rd times 5 to the 3rd. And that ends up, we know how to do this, 5 to the 6th. All right. So then you're going, let me try another one. Okay. So what if it was 3 to the 8th raised to the 3rd power? Okay. Well, anything raised to the 3rd power is that thing times itself 3 times, right? So 3 to the 8th times 3 to the 8th times 3 to the 8th. Well, hang on a second, because I know that these are all multiplied. They all have the same base, so I can add. So this is going to be 3 to the 8 plus 8 plus 8. Okay. Or 8 plus 8 is 16 plus 8 is 24. Okay. So in both of those cases, I'm kind of like, well, what did we do? Okay. We didn't add because we only add when we're multiplying, right? This is an exponent raised to an exponent, okay? Or a power raised to a power. So whenever I have something raised to an exponent and that is raised to an exponent, what we did was we did 3 plus 3, or 3 times 2 gives me 6, right? So here we did 8 plus 8 plus 8, that gave me 24, or we could have said 8 times 3 gives me the 24, okay? So let's try one more and see if it still holds. What if it was 2 to the 5th raised to the 5th, okay? Well, that would be 2 to the 5th times 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 2 to the 5th. I need 5 of them, right? And we know these are all multiplied together. They've all got the same base. So that's 2 to the 5 plus 5 plus 5 plus 5 plus 5. But when I add those 5, 10, 15, 20, 25, that is 2 to the 25th. And we say, well, 5 plus 5 plus 5 plus 5 plus 5 is the same as 5 times 5, right? So what we're seeing is when we have a power raised to a power, we can multiply those exponents, okay? So when you have something raised to a power, I'm going to say exponent, something raised to an exponent, and that is raised to an exponent, we will multiply the exponents. We will keep the base and multiply the exponents. Okay, so what does that look like with variables in the mix? Okay, it might be something like x to the second raised to the fourth power. Okay, and you can multiply all those out, x squared times x squared times x squared times x squared if you want to, or you can say this is x to the 2 times 4. Okay, that's what it means. Keep the base the same, multiply the exponents. And we know order doesn't matter on this, so if you wrote 4 times 2, it won't matter. We still get x to the 8th, right? Okay, so what if it was like z to the 5th power raised to the 3rd? Okay, well, it's keep the base, multiply exponents, 5 times 3. So that'd be z to the 15th. That's what we're looking at. Okay, so hang on just a second. I'm gonna pause the recording and make sure I got all the exponent rules I want you to have. And if so, then I will be done. So give me just a second. All right, so there is one more exponent rule I want to make you aware of, and that is one with a fraction. So for instance, if I had, let's say 25, the square root of 25, we know that's 5, right? Okay, let me rewrite this though as the square root of 5 squared. Okay, and what I will say is whenever I have a square root and a square, those are opposite operations. Those are going to cancel each other out. We know that. So that's why the 5 just pops out, right? But we know that this is a 2 sitting there, right? Okay, so when I take this, this is actually 25 to the 1st power and the square root. So what it ends up looking like is this. You do 25 to the, here's the power that goes on top. Here's the root that goes on the bottom. So a friend of mine once said that the roots are on a plant go on the bottom and the power in a flower is all on the top. So that's where the petals and stuff come out. But if you look at it, it looks like 25 raised to the 1 divided by 2. And that's what the 5 would look like. So this becomes a 5 because I say 25 to the 1/2. Okay, that's a 5. So there is this exponent rule that says if you have something inside a radical or a square root, you can put the exponent on the top of a fraction exponent and the root or the index from the radical, that's what this guy is called, right? So this could be like a 2, a 3, a 4, whatever, on the bottom. So it looks like this. X to the A root B, okay? This is going to turn into X to the exponent goes on the top and the root there goes on bottom, okay? And the radical goes away because we have rewritten it as a fraction exponent, basically. So this is where you get fraction exponents from. All right. So it's going to look something like this. What if I had the cubed root of 8? Okay. Well, that would end up being, what's the exponent here? I didn't write 1, but it's really a 1, right? So 8 to the exponent goes on top, 1, divide by the power or the root here. The root or the index, I should say, is a 3. So on my calculator, I can say 8 raised to the 1 divided by 3. Now we know the cubed root of 8 is 2, right? So 2 times 2 times 2 gives me the 8. And so does my calculator. So this gives me a 2. Okay, yay. So it works, that rule works. And whenever we go over into the exponent world, it's going to look just a little bit ugly sometimes. So prepare. If I had something like this, x squared, and I'm taking the 5th root of it, then that's going to be what? X to the exponent or the power is on top, 2. And the root or the index is the 5, it goes on bottom. So the little picture that we do is power over root. And so it looks like when we talk about flower power, here's the power of the flower. And then here are the roots. So the power is on top. We can see that one on top. The roots are on the bottom. Okay. So if that helps you to remember where those things go, then great. Keep it in mind. That's how the fraction exponents are going to work for us. Okay. So in your homework, I believe you have a review over exponent rules. So that's what this is all about, getting us prepared to look at exponential and logarithmic functions after we come back. So take a look at all these exponent rules, make sure you feel comfortable with them, and I will talk to you soon. Thanks. Bye.